The James Webb Space Telescope has revealed something truly astonishing. Beams of light that seem to emanate from a bustling metropolis, shining from a location 4 light-years away. This amazing discovery has rekindled our interest in the possibility of the existence of extraterrestrial life. The telescope turned its attention to Proxima Centauri b, the closest exoplanet to our solar system, and detected mysterious, dazzling flashes of light. Could these signals be evidence of an advanced alien civilization? Stay tuned as we unravel the mystery. For centuries, both scientists and the public have been captivated by the idea of life beyond Earth. Any hints of extraterrestrial life have sparked widespread excitement. However, a significant breakthrough occurred when the James Webb Space Telescope uncovered clear indications that life might exist elsewhere in the cosmos. While peering into the vast expanse of space, this remarkable telescope made an incredible discovery. It found lights on an exoplanet far away, reminiscent of the glow from alien cities, raising the tantalizing possibility that a thriving metropolis could exist on this distant world. This concept has ignited a firestorm of intrigue and anticipation within the scientific community, as it could be the monumental revelation they've long awaited. It suggests the existence of intelligent beings managing civilizations in ways we are only just beginning to imagine. From an awe-inspiring distance of 4 light-years, NASA engineers are stunned, wondering, how long have these lights that look like cities, been visible, quietly waiting for our technology to evolve to the point where we could detect them? David Kipping, an astronomer at Columbia University, has described the planet where these lights were observed as intricately unique. Unlike the majority of rocky planets that convert sunlight into energy and infrared radiation, this exoplanet behaves in an entirely different manner due to its unusual interaction with its host star, Proxima Centauri. This remarkable discovery by the James Webb Space Telescope highlights the telescope's pivotal role in unlocking the mysteries of the universe. Its ability to capture infrared wavelengths was critical in identifying the peculiar behavior of Proxima Centauri b, which is vital to understanding the planet's atmosphere. The significance of this finding has prompted scientists to plan further studies using the telescope to explore the atmosphere of this planet in even greater detail, with the hope of uncovering whether it could sustain life. The Webb telescope, with its exceptional sensitivity to infrared light, allows us to observe Proxima Centauri b's behavior even during the planet's night. While many telescopes struggle to detect faint light in the vast blackness of space, the Webb telescope excels at catching even the tiniest flickers, making it the ideal tool for determining whether the mysterious city lights on the dark side of Proxima Centauri b are in fact real. The telescope can detect artificial light in space, provided it falls within a very specific frequency range, much narrower than the light emitted by regular stars. Proxima Centauri b has a dynamic relationship with its star, which profoundly impacts its environment. Like many planets, it takes in a lot of energy from Proxima Centauri as it orbits its star. The planet cycles through periods of day and night much like Earth. During the day, the planet experiences scorching heat, while at night, it cools down significantly. The temperature fluctuations on Proxima Centauri b are vast, mainly due to its unique composition. For instance, if the planet has no atmosphere, the temperature difference between day and night could be extreme, scorching hot to the touch on one side, and dramatically freezing cold on the other. This thermal variation is extremely intriguing to astronomers, offering valuable insights into the makeup of Proxima Centauri b's atmosphere. Thanks to the capacity of the James Webb Space Telescope to capture infrared images, scientists can effectively study the planet's thermal emissions and attain a more in-depth understanding of its atmospheric properties. The role of Webb in these future discoveries is crucial. Interestingly, the orbit of the James Webb Space Telescope around Earth coincides with Proxima Centauri b's orbital period. That allows scientists to observe the planet's daylight cycles every 11.2 Earth days. If Proxima Centauri b harbors an atmosphere, the next logical step will be to analyze its chemical makeup to determine if it could support life. Detecting key elements such as oxygen, water vapor, and methane would indicate that the planet has the potential to harbor life. This would involve studying the filtering of light through the planet's atmosphere, a complex process in itself. While the James Webb Space Telescope excels at analyzing planetary atmospheres, its primary purpose lies elsewhere. It is particularly adept at measuring concentrations of water vapor, carbon dioxide, and methane, but is not as efficient at detecting free oxygen, a crucial sign of biological activity. Nonetheless, the telescope can still look for additional significant indicators, like ozone, which signals a healthy, life-supporting atmosphere. As researchers continue to analyze the data the Webb Space Telescope gathered, the search for distant worlds progresses. This search is bringing us closer and closer to answering one of humanity's most profound questions: are we truly alone in the universe? It's important to recognize that the James Webb Space Telescope is only able to observe a limited number of exoplanets that are relatively close to the surface of the Earth. To delve deeper into the study of planetary atmospheres, astronomers will rely on ground-based observatories such as the Extremely Large Telescope, ELT, which is set to begin operations in 2028. The ELT is designed to provide a more in-depth examination of the atmospheric structures of far-flung exoplanets, offering clearer and more precise data on their potential to support life. Final thoughts. Researchers have ambitious plans for future space telescopes. These instruments aim to develop technologies that minimize starlight interference, enabling better observation of the planets that orbit around them. Much like shielding your eyes from the sun to see more clearly, these future telescopes will be able to focus on the faint light reflected by exoplanets, making it easier to analyze their atmospheres and assess their potential to support life. However, this task is no small feat. Stars are incredibly bright, often overwhelming their neighboring planets with their luminosity, making it difficult to detect the faint light that planets reflect, essential for studying their characteristics. To tackle this problem, scientists are exploring a range of innovative methods. One promising technique involves the use of coronagraphs, special devices placed inside telescopes to block starlight while allowing the planet's light to pass through. By carefully manipulating the light waves, coronagraphs can reduce the brightness of the star, making it easier to detect the dim light of exoplanets. Another exciting approach is the star shade, a spacecraft the size of a huge flower, designed to fly in formation with a telescope positioned tens of thousands of kilometers away. The star shade will block starlight before it reaches the telescope. The star shade will block starlight before it reaches the telescope's optics, allowing only the faint light from surrounding exoplanets to be observed. This innovative tandem system enhances contrast and clarity, making it significantly easier to detect small, Earth-like planets orbiting distant stars. Together, coronagraphs and star shades represent a new frontier in astronomical observation. These technologies will enable scientists to directly image exoplanets, analyze their reflected light, and gather data about their surface and atmospheric composition, critical steps toward identifying signs of life. In the coming decades, missions such as LUVOIR, Large UV Optical IR Surveyor, and HABEX, Habitable Exoplanet Observatory, are expected to expand on the foundation laid by the James Webb Space Telescope. These future telescopes are being designed with the specific goal of detecting habitable worlds and signs of biological activity. Each discovery brings us closer to answering age-old questions. Is Earth unique? Is life a cosmic rarity or a common phenomenon? Are there civilizations out there, watching the stars as we do, wondering if they too are alone? The James Webb Space Telescope has opened a new chapter in our understanding of the universe. Its unprecedented sensitivity, resolution, and capability to peer into the earliest epochs of cosmic history, as well as to distant planetary systems, have transformed theoretical possibilities into observable phenomena. As the scientific community eagerly awaits further data, one thing becomes increasingly clear: we are on the brink of a new era in space exploration, one that may finally reveal that humanity is not alone in the cosmos. The stars have always held our imagination. Now, they may hold our neighbors. Even enters the telescope, ensuring that only the light from the exoplanet reaches the instruments. This technique could prove especially effective for observing planets in the zone that can support life, regions around their stars where liquid water and possibly life could exist. These advanced technologies, however, require exceptional precision. For instance, aligning a star shade must be done to the nearest millimeter fraction over vast distances. Furthermore, the obstacles posed by space missions, such as the need for miniaturization, energy efficiency, and the ability to endure the harsh conditions of space, must be overcome by innovations. Despite these hurdles, the potential rewards are enormous. Effectively observing and analyzing the atmospheres of exoplanets could lead to the discovery of biosignatures, chemical indicators of life, such as oxygen, methane, or water vapor in specific ratios. These molecules could indicate the existence of biological processes, providing compelling evidence that life exists beyond Earth. In addition, researchers are looking into ways to directly capture images of distant worlds in far greater detail. Future telescopes could be equipped with sophisticated adaptive optics that correct distortions caused by Earth's atmosphere or the movements of the telescope itself, producing sharper images. When combined with starlight blocking technologies, these improvements could make it possible for scientists not only to detect exoplanets, but also to map their surfaces and examine their climates. The development of next-generation space telescopes represents a monumental leap forward in our search for an answer to humanity's most profound question: are we alone in the universe? By enhancing our ability to observe these distant worlds, we are drawing closer to uncovering whether life exists beyond Earth, potentially revolutionizing our understanding of our place in the cosmos. The future of space exploration and the search for life beyond Earth is advancing at an unparalleled pace. As scientists and astronomers probe deeper into the mysteries of distant exoplanets, the James Webb Space Telescope is ushering in a new era of cosmic discovery. The data it gathers is helping astronomers make groundbreaking revelations about the structure, composition, and habitability of far-off worlds. With every new piece of information, we move closer to answering the ultimate question: is there life beyond our planet? Proxima Centauri B's discovery is just the beginning of what could become a monumental turning point in how we study extraterrestrial life. As the closest star to our own solar system, Proxima Centauri has been the subject of intense research for years. Yet until now, the idea of discovering concrete evidence of life, like artificial light or signs of civilization, seemed like a distant dream. The fact that such light has been detected by the Webb telescope only heightens the hope that one day we may come into contact with other intelligent beings inhabiting the universe. This kind of discovery sparks both scientific curiosity and public imagination, inspiring new generations to look beyond the boundaries of Earth. As the James Webb Space Telescope continues its observations, it's not just searching for artificial lights but also focusing on planets' atmospheres, their chemical makeup, and the conditions that could support life. The hunt for biosignatures like methane or carbon dioxide in the right concentrations is essential for figuring out whether these planets could sustain life. The Webb telescope's unique ability to examine these atmospheric components illuminates the potential of distant worlds to possibly support life similar to Earth's. The most captivating aspect of this endeavor is that we are observing the past. The light from these planets takes years to reach us, meaning what we see today actually happened years ago. Each glimpse into the past is what discovery is: a cosmic time machine showing us the universe as it once was. As evidence from the James Webb Space Telescope continues to pour in, humanity stands on the brink of a new era, an era where questions once considered impossible, such as the existence of alien civilizations, may finally be answered. The implications of such discoveries extend far beyond science. They touch philosophy, religion, and our fundamental understanding of what it means to be human. The realization that we may not be alone in the universe forces us to reconsider our uniqueness, our place in the grand design, and our responsibilities, not just to each other, but to the cosmos as a whole. As new instruments come online and older ones are refined, the precision with which we can observe the cosmos will only increase. Missions like the Nancy Grace Roman Space Telescope and the European Space Agency's Aerial Observatory promise to provide even more detailed data about the atmospheres, compositions, and potential habitability of exoplanets. Combined with artificial intelligence and machine learning, these tools can analyze massive amounts of data at speeds never before possible, uncovering patterns, anomalies, and clues that human eyes alone might miss. At the heart of it all remains a simple but profound goal: to find signs of life beyond Earth. Whether that life takes the form of microbial organisms beneath the icy crust of a moon or civilizations transmitting signals across the stars, its discovery would forever alter the narrative of our species. It would answer one of humanity's oldest and deepest questions and simultaneously raise countless new ones. What would such life look like? How would it function, evolve, or communicate? And most importantly, could we understand it? Our current generation stands at a threshold. The tools are in place. The knowledge is growing. And the will to search, relentless and inspired, burns brighter than ever. Every photon captured, every data stream analyzed, every anomaly investigated brings us closer to a future where the cosmos is no longer a silent expanse but a conversation waiting to be heard. And when that moment arrives, when the faint signal is decoded, or the unmistakable trace of life is confirmed, it won't just be a victory for science. It will be a moment of collective awakening for all of humanity.